Let's move on to our extinction segment. What is that about? Well, here we say that we are the last generation of humans on Earth. Now people say, well, you have a crystal ball, Bill? Are you an astrologer, palm reader or foreseer or whatever? No, this has nothing to do with the future, really. It has to do with the past. What we do here is science, and science is about explanations, mechanisms in the case of physics, and that's what we do here. We explain mechanisms. And what we're trying to explain here is the mechanism that leads to extinction, especially to a mass extinction. And that's what that's how our species is going to disappear, in a mass extinction. Okay, so what we do is, instead of going to the future and saying, look, what day is the last human on Earth going to die? We don't do that kind of thing. That's stuff for mathematicians. All those people, they like to do all that stuff, predictions. We don't do predictions. We do explanations. And so we have to go to the past. And some people might say, well, hold it. The extinction of man hasn't happened. What are you going to explain? And so this is what we have to understand, the context. The context is as follows. We go to the past and we figure out how animals in the past died, disappeared. Okay? And we look at the mechanism. What made them disappear? Why did they become extinct? And we extrapolate that to the human race. And if we cannot, with all our technology, all our foreseeing, and all our projections and seeing ahead and being able to react on time, if we, with all the intelligence that we have, cannot avoid the same mechanism that made the animals in the past disappear, made them become extinct, then not only do we confirm that that is what killed those animals, but it shows what we're going to die of as well, if we cannot avoid whatever hit them, whatever struck them, okay? And so how did the animals in the past die? And that's the first question we need to answer. And here you have the official versions out there from the establishment, paleontologists, and you have for different eras, for Cambrian, Ordovician, Silurian, Devonian, etc., right? And what do you find? Well, you find almost always the same mechanism. Volcanism, anoxia, changes in sea level, global cooling, CO2 depletion, climate change, methane plumes, and the famous and most popular ET impact, an asteroid. There, they fixed the problem. Asteroid, right? And a lot of these have to do with what we talk about in the news today, global warming, that kind of thing. And so people get enthused because of that. It's more a political issue than a scientific issue. Okay? And of course, the main one here is the extraterrestrial impact. That's what these people essentially propose. And whenever they don't have a solution to the problem, they say, oh, it was volcanism, if it was way back when, and nobody was looking, or it was an extraterrestrial impact. And so since volcanism is probably not, no volcano is going to kill all of humanity, and we don't expect a hit from an extraterrestrial meteorite or bolide or asteroid or whatever, then we say, oh, we'll live forever. Right? Because none of them will kill us, right? Well, that's only if that's true. And here, let me summarize what these people are proposing. Here it is, essentially ET impact, climate change, volcanism, greenhouse effect, ocean acidification, degradation, some people propose, and la, 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 la. There are much more. None of these can explain the only thing an extinction theory has to explain, a mass extinction theory has to explain, and that is selectivity. How does Mother Nature choose one's order, bunch of species out there, and leave all the others alive? And that applies to both animals and plants. Okay, so that's the only issue that they cannot explain: selectivity. Now, and anyone who cannot explain selectivity does not have a theory of extinction. And we haven't had a theory of extinction in the last 200 years since Georges Cuvier invented paleontology, or the French his co-religion, his friends out there. They all invented this discipline, and nobody can explain 200 years how animals disappeared. 200 years, over 200. That was in the late 18th century. Okay, so what do we propose? How do species disappear, both plants and animals? Well, we're not going to deal with plants today because that's a lengthy one and has to do with background extinction. We're not going to do background, we're just going to do mass extinction. And here you have the picture that explains it all, okay? And what you have here is that when the plants disappear, the animals that fed upon them, the animals that depended on them, disappear as well. And so just to look at a couple there, you had the seed ferns, especially in the Permian Triassic, right? Glossopterids and what was it? I can't remember the name of the other one in Triassic. But this is when the seed ferns disappeared, and we don't have seed ferns today. We have different types of ferns today. When they disappeared, these animals disappeared. Okay. What happened in the Jurassic and Cretaceous? Well, what happened there was the conifers. This was the age of conifers, the gymnosperm. And when they disappeared, types that were around when those animals were around, when those animals couldn't find anything to eat, that's when they disappeared as well. And you can predict that whenever the angiosperms disappear, we disappear. Okay? And that's about to happen. Why? Because, again, you know, the issue is not an asteroid hitting the Earth. It's not disease, climate change. None of that has anything to do with extinction. Now, what we propose here is that there are economic collapses. And yes, all animals have economics. Economics is the management of resources. And the resource that all animals manage is food. When food disappears, the animal disappears. That's how simple it is. It's guaranteed. And when food disappears for humans will disappear. And so that takes us to the point where people say, well, why will food disappear? Okay? And that's the next step, okay? But here, let's still give you an example here, okay? And here you can see that when the conifers were essentially muscled aside by the angiosperms, that's when the dinosaurs disappeared, the Cretaceous, okay, at the end of the Cretaceous. And you can see how little by little the angiosperms, not so little because it was millions of years, but you can see how the angiosperms, the number of species, were covering the land. They were multiplying in number of species and obviously as well in extent of how many of them there were. And so the dinosaurs were multiplying, but they were finding fewer and fewer food sources. You know, what was disappearing is their islands, their forests, their jungles. That's what was disappearing. So their islands kept getting smaller and smaller and smaller, and they were multiplying. They were getting more numerous, and at some point there was a critical point, and they disappeared. Okay, so that's what we propose here, that all mass extinctions have to do with economic collapses. Okay, and our economic collapse is about to happen very soon. Soon meaning, you know, this century for sure. And you know, if we have world wars like nuclear wars, that's just going to accelerate the process. But even the nuclear wars are an issue of economics. It's the fighting for resources. Okay, it's the struggle for resources. Okay, so the other day I presented this fellow. His name is John Calhoun. He ran his mouse experiment. First his rat experiment, then his mice experiment. And he did that from 1947 all the way to 1973. So he had many years doing these experiments, these observations. He was a psychologist, a behavioral psychologist, so he was interested in what the effects of density, right, would have on the mind, on the, on the behavior of animals, especially these animals which reproduce quite swiftly. So he wanted to see if the colony expands, you know, how does that affect the minds of the future generations? And you have to remember he started out with 4 pairs of mice, 4 couples. Each mouse chose its mate, and they started building nests. And that was great. It was that was Adam and Eve, more or less. They were in paradise. But as time went by, even though the food sources and water was given to all the animals at all times, they had unlimited food supply. They didn't have to go out and get it. They could just get it from the mechanisms that John Calhoun created for them. And so, yeah, they were able to live in paradise, then began to multiply. And a few months later, what you have is 2,000 mice, 2,200, I think it was, or thereabouts. And then the colony began to decline. The population began to decline, and towards the end, they ended up in extinction, or in, I think he stopped the experiment a little short of extinction, but they were on their way to extinction. But more importantly, he found out that towards the end, the mice became homosexual, asexual, and autistic, which pretty much resembles our society today. So we're in that last stretch as well. That's what the world we have that we live in today. Okay, so this is the chart. You can see it here. You can see how the mice multiplied, and then reached around 2,000 mice, some thereabouts, and then they started dropping until they ended up with extinction. Okay, so that's the curve that Calhoun made, and he wrote a couple papers on that. Okay, so one fellow says the following, because he watched a video by Ed Dutton, the Jolly Heretic, and says, I believe Mr. Dutton's criticism stems from the multiple scenarios or universes from Calhoun's experiments. The beautiful ones, those that towards the end were autistic, homosexual, etc., right? Did emerge in one such universe, but it did not occur in every colony. I don't think it harms your extinction assumption, since you only offer a possible explanation in your current predicament, and Mr. Calhoun did show that, at least in mice, such an explanation is possible and understandable. Well, the issue is that I brought against Dutton is that Dutton said there are contrary results from other experiments. I didn't see that. Calhoun never had other, contrary results, and I haven't seen any other experiments that reproduce Calhoun's experiments. If you know one, I'd love someone to send it to me. I'm willing to change my mind, but I haven't seen it. I've looked for someone running the same experiments no one has. So I guess everybody just accepted what Calhoun did and left it at that. And here you have, this is Calhoun's paper on rats, which he wrote in 1962, right? And he essentially describes what happened. So it happened to the rats as well as with the mice. He says, many female rats were unable to carry the pregnancy to full term or survive delivery of their litters, right? An even greater number, after successful giving birth, fell short in their maternal functions. They would wean their children, their offspring, early, and other mice would kill them, other rats would kill them, this is the rat, would kill them, and it's like the female didn't care. She no longer wanted to have relations with the males. So they had all kinds of problems of that nature. That's what affected their psyche, their minds, right? And so there was full disruption, as he says there, right? And that's what happened to the rats. The mice, he wrote about that a few years later, and here's the mice one, okay, the mouse experiment. To day 600, the social breakdown continued and population declined towards extinction, okay? So, and you can read about his experiment, but essentially, he called them the beautiful ones, the ones that just ate, drank, slept, groomed themselves, all solitary pursuits, individualism, sleek, healthy coats, and an absence of scars characterized these evils. Okay? And he says, breeding never resumed. Behavior patterns were permanently changed. Okay? So, yeah, the issue is that I think if we ran the experiment again, we would get the same results. That density has to affect their mind. They had all these encounters with many mice, And I guess that somehow affected the way of thinking. And again, these are mammals, right? And are we any different? And they ran other types of with experiments with humans, and they said, well, we're different. Well, we're not. And it's not a question of populating the earth. I want to make sure that people understand it. Mother Nature's running the experiment with us. We're the guinea pigs here, right? But it's not in the same way that Calhoun did it in this sense. It's not that like we're in a little pen, corralled in there, and that we're all, elbow to elbow. That's not the issue. The issue is with humans is that we move from the country to the cities, and that's when we stop having babies. We can't have children in the cities. Cities are no place for children. In the country, our great-grandmothers, they had 10 children, 15 children, no problem. Half of them died, no problem either. As long as someone survived and carry out the dynasty, no problem. But that's not the case in the cities. In the cities, you cannot have children. And people think that it's a question of people being poor, people being rich. No, in the 19th century, it was the rich people who had children. So it's people have all those facts wrong. The people who had children in the past were the rich people. And today, nobody, the rich or the poor, have children, except in the country. So in the country, you'll find poor people, in a lot of countries, and they have 10, maybe 7 children. I don't think anybody has 10 or 15 anymore, but they probably have 7 children. But once those children move into the cities, I don't care if they're ignorant or intelligent, I don't care if they're rich or poor, they will not have children. Okay? So we stop having children when we come to the cities. That's where the density issue occurs. Okay? And we're also getting the homosexuality and autism that we see in Calhoun's experiments. Okay? So what's the trend with humans? Okay, how do we look as far as population is concerned? Well, here it is. I showed this the other day, the world population growth, the pink graph there. It's going up still, but it's going up at a slower rate. It's asymptotic growth. And you can see why. The green line tells us the growth rate. The growth rate is falling. Okay, and as it falls, right, the total population curve becomes asymptotic. And by the mid-century, there's been a prediction, again, from the UN demographic group saying that, we're going to reach zero population growth, otherwise known as ZPG. And then I guess there's only 3 possibilities. We either continue upwards, we continue downwards to extinction, or we go more or less, up and down, at the same population, more or less. So which trend are humans going to follow? Our species going to follow? Well, we're going to go into extinction if nothing else happens. But something else will happen, and that will be the collapse of our economy, because we don't die in a background extinction, which is if the trend goes downwards, right? No, we die sooner than that, and maybe fortunately. We die in a mass extinction. That's going to be a food extinction, okay? Okay, so here's the trend since 1963. You can see the growth rate has been falling steadily. And at some point this century, somewhere, they say 2050, maybe earlier, maybe later, we're going to reach ZPG, okay, zero population growth. Okay, so just keep that in mind, what's up and coming. What's happening to our population also is that our population pyramid is overturning. Okay, that means we have more and more older people and fewer reproductive people. Okay, people who can reproduce, and those are the young ones. They're coming to the cities, and of course they have no interest, many of them, in having children. Others have no economics to have children, and so yeah, all those factors contribute to the population inversion, the pyramid inversion. Okay. And so one fellow says there are different findings as to whether population growth will slow down or even stop at home. And he goes in there and shows different bits of information he found on the internet of different calculations of when we're going to peak out, when we're going to reach our maximum extent. And there are different calculations, but you have to remember all these are calculations based on mathematics alone. There's very little consideration in general for for what's actually happening qualitatively. In other words, the fact that people are moving from the country to the cities, and when they move to the cities, they don't have children. They just look at numbers and they say, well, if the trend has been this fast so far, then by such and such day, we're projecting to have so much people. And they put some qualitative factors in there to get a better idea. But again, you cannot predict that. No mathematician can tell us what people are going to do. And people are going to react based on their economic environment. If they don't have a job, they're not going to have kids. And if they can't pay the mortgage, they're not going to have kids. And there are so many other things that we have to look at before we can calculate anything. So calculations, I think, are all irrelevant. All of them. We have to look at this qualitatively and say, look, people are moving from the country to the cities. In the countries, they had lots of kids. In the cities, they will not. And they won't have kids, and that means that our population decline will probably be faster than what we think, especially if you throw in there the fact that, the population is getting older because we are producing fewer young children. And so the population pyramid is overturning. There's no place for the new generations to go to work. They're going to have fewer children. The culture is also changing. There's no more of this culture of having children anymore. That's dying. So all this contributes to the population inversion. And obviously there's this final, icing on the cake, which is the mechanism of our economic system. And here it is. This is another factor you got to consider, which is, I showed this also the other day, this is density-dependent birth rates. The more dense, the fewer children that animal has, that species has. And we're at the top of the list. We're subject to density-dependent birth rates, and so are all those other mammals there. Okay, so it's not only us; it's all the mammalian world. Okay, terrestrial animals, right? And what happens? The more density you have, the fewer children you have. And that's more or less what happened to Calhoun's mice as well. Okay. And here you have another factor that we throw in there just to make things a lot worse, okay? And that's that we have no genetic diversity anymore. We are all clones of each other from a genetic point of view. You take any person on Earth, I don't care if he's in China, in Africa, South America, you compare them and you'll find that there's relatively little genetic diversity across the planet. And they compared it against chimps, troop of chimps, maybe 100 to 200 chimps in Africa, and they found out that the chimps, the small group, maybe, again, anywhere between 100 to 200 chimps, they took samples there, and the genetic diversity of the chimps were greater than the entire human race of 8 billion people. So that's an eye-opener. They don't know why, and yes, we do know why. In science, they don't know why in genetics, but in science we do know. And what we found in science is that, genetic diversity for a species can only decrease over the hundreds and thousands of years. We've been inbreeding for maybe 200, 300,000 years since the origin of our species. We haven't had any influx of new genetics into our pool. We haven't slept with monkeys or cows or fruit flies. So we've been inbreeding, and inbreeding only leads to loss of genetic diversity. If you add to that, population bottlenecks and founders effects, well, then you get the big picture. Yeah, we do have mutations every day, right? Everybody, our population in general. But then you have these big, population bottlenecks where lots of people get wiped out, and that streamlined our genetics and our genetic pool. And today we're all clones of each other, essentially. Okay? We're all equal. Whoever you marry out there is your brother or your sister from a genetic point of view. Okay, and here's our proposal. We're saying, why does humanity disappear? Do they disappear because of genetic diversity? No genetic diversity. Does it disappear because our population pyramid overturns? No, these are signs that take us to the real issue. And the real issue is here. It's the economic modes through the ages. And that is for 200, 300,000 years, we were hunter-gatherers. For maybe 10, 15,000 years, we were farmers, agriculturalists. Then maybe 200, 300 years, we became manufacturers. We got into industry, the Industrial Revolution, right? And that's when we started industry. And from there, we moved to what we have today, which are services. And maybe in the last 10, 15 years, we went into a special type of services, which are internet services. So it's no longer this labor-intensive service like, barbering or landscaping or anything like that. It's now internet. It's, there's no hands-on. So we had this trend over thousands of years, and now we're at the end of the line. Why? Because, right now we have fewer and fewer jobs, real jobs. All we're doing is services, and services is another word for unemployment. Anyone doing services is unemployed, okay, because you're not producing anything. Someone sings, and you send them some money. And so what did we get? The song went away, carried by the wind. The money is just an abstraction that we give value to because we decide to accept it because we can do something with it. And when you stop to think of it, all we're doing is exchanging all these services for food. We'll work for food, that's what it is. And the way we look at this really to see if there's any real growth is we put ourselves up there in the sky with God, devil, or Mother Nature, whoever you believe in. We look at the earth from up there. We have this bird's eye view and say, what is real? And what is real are the houses, the streets, the cars, the bridges, the farmlands, whatever grows into farms. All this is real. What's unreal is services. Services doesn't exist. Services is a contract, maybe insurance. What is insurance? It's a promise. Well, we can't see the promises from up there. So the issue is, you can see growth only when you see manufacturing or agriculture. And that's now become a small percentage of every country's economy and becoming lesser and lesser every day. What's growing is services. And services, again, is another word for unemployment. Okay, so we go to the definition of a mass extinction. What is a mass extinction? You see it there at the bottom. Mass extinction, the disappearance of an entire food chain. One food chain disappears, the other one continues. Okay, why? Because they're not eating the same stuff that the other species are eating. Okay, so the dinosaurs were eating conifers primarily because they grew with the conifers. They grew with the gymnosperms. Okay, and here we were, the mammals, and we didn't care about conifers. We don't eat conifers. What were we eating? Well, we were eating angiosperms. And so as the angiosperms were expanding, we expanded with them, and angiosperms were taking over the land. The islands of the dinosaurs declined as they were becoming more numerous, and at some point there was a critical point where their population began to drop. Okay, and they ended up in extinction. Why? Because at some point they ran out of food. That's what happened. And meanwhile, we continued growing with the angiosperms, and we were in a different food chain. And the same thing happened when the Permian synapsids died, and the same thing with the archosaurs in the Triassic and so on the line. The archosaurs disappeared when the dicroidiums disappeared, which was a seed fern also. And the Permian synapsids, they died disappeared, right? When Losopterids died or disappeared. And so we can map the disappearance of plants and the disappearance of animals that depended on those plants. Very straightforward. So now you know. That's what we propose in this channel, and we're saying that we're due for extinction very soon. Why? Because as you can see the trend in that graph, the modes of production, the years that we ended up in a given mode of production become smaller and smaller and smaller, almost exponentially. We went 200, 300,000 years as hunter-gatherers. It took us a long time to develop, finally agriculture. We spent only 10, 15, maybe 20,000 years at most in agriculture, which I doubt, probably more likely 10,000, it's just the what came after the Paleolithic, And then you have like 300 years of manufacturing, and that started in the Industrial Revolution, give or take, say even the 16th century if you want, and onwards. And today we're in the service mode. We don't do manufacturing, we don't do agriculture because those have become ultra efficient. And what we do now is just, fool around with the computers. Okay? And so, yeah, that's the proposal here in this channel. We're about to become extinct very soon. And if we go into wars, that's just going to accelerate the process.